Thank you. Hello, everyone. Morning. I recognize some of you, quite many actually, which I think is good and interesting. So today I'm here to give a view on, say, from the device side and a few aspects of how we within Sony think that the use cases and wireless revolution or evolution, whatever we find out on the new interfaces, will improve and how it can improve. So I just need to introduce Sony devices with a few slides, and then going into, say, we're looking to 5G on what we call extreme use cases. So we know that we will cover the things not only 2020 but still further away. Some few thoughts about the evolution and revolutionary aspects I will also touch upon and give some background information. Then one thing that maybe will be from Sony as a device company, a few hints on how you implement these things, implementing in aspects of the technologies in the wireless devices and how they can be with some pros and cons of those things. Specifically looking at the multi-antennas, since that is a key. We everyone agrees that we need to look into those parts with the antennas and frequency bands. Then a reflection on how to building the 5G scenarios when we go forward to 2020. So first, Sony, you know it, but some from Sweden, you know, maybe don't know that Sony, of course, it's a big company, but Sony Mobile in Lund, Sweden, we are also a big site, more than 2,000 employees, and we are part of driving the Xperia, the smartphone, in addition to all the other, say, Sony Music, Sony Picture, digital imaging, and the network entertainment parts. So we're really part of the whole Sony global, of course, headquarters in Tokyo, 170,000 employees. So we are a big company. The philosophy of Sony, and that's why I'm here to try to represent today when we talk about 5G, is, well, we use this. It's about technology, it's about use cases, but actually we need to move emotionally. That's why we say, that's why we pay for things and use the things, if we can be moved by them. And this is really, say, the can-do philosophy of Sony here. So a hint, as you see here, when we talk 5G, you talk about vertical integration. Of course, there is smartphone and tablets in the center, but all the other devices that we have, from the large TV sets to headphones, smartwatch, everything must, of course, be connected. All these are not connected to mobile networks today, but hopefully they will be, so we can simplify for all kinds of markets and places to use. So the devices and then the services from music, album, video services, and Sony, all the way to contents and movies like James Bond. That is within the width of Sony family technologies, devices, and services. Of course, I need to start here being at Sony Mobile with a smartphone. We all know, and we have seen, this is just where we start and then extrapolate from where we are today into the 5G, I think, because this is the center of the user's life. I mean, I see here, independent almost of age, that the smartphone is the center. You check it, I don't know, 80, 90 times an hour, some for the messages and emails, but you create the content, you use the information and content from the cloud, you share the content between the devices, and you control other devices. All this, that is what we have today, and now we only need to extrapolate from this. So the smartphone has access to all the user information, the account information, sensor data, positioning. There are already lots and lots of things, and maybe not all use everything. But it's in here, and we connect to the cloud, and we use local data and local processing also in the devices. This is, say, the starting point from this. But then going forward, I will look into 5G or whatever we call it, 2020, some years ahead, with extreme use cases. Because if we only take a kind of evolutionary path towards, like this 5-10% annually improvement, maybe we cannot solve these two extreme use cases that we now in Sony want to highlight. One is, say, the live streaming use case. We already saw from Nakamura-san on 4K and 8K streaming, and of course this is one thing that we Sony think is really important going forward. It could be a stadium case. It can also be like at home residential. It can even be at office where you want to do this real streaming with extremely high quality, multi-camera, multi-view, multi-perspective. And if you compare to today, I mean, when we add by a factor of 4 going from full HD to 4K, we add another factor of 4 from 4K to 8K. So there are hundreds of megabits per users, per stream, even if you have the most advanced technologies. And of course that ends up to lots and lots of megabits in the air per user. So that's one, it's an extreme case when you build up the 5G system. More on the other side, the other extreme is kind of the wearable case. Wearables is we can call it a subset of Internet of Things, machine to machine, but the devices that you carry on, wristlet, smartwatch, headphones, earphones, all kinds of sensor data. And here is the low, maybe moderate, but mainly the low bit rates, and of course the low power consumption, and low, it should say maybe the extremely low power consumption for these devices, because they must be tiny, not small. Tiny and wearable and connected all the time. So from this, I mean, I don't show here all the user experience in between, because they will be there when we evolve. But I think we need to also support the extreme use cases for 5G to have it as an additional improvement compared to the ordinary 4G. So 2 hints on these. If you say the streaming, the roadmap to 8K, and say, oh, why do we need 8K, and maybe this is not important. But of course we think it is, and it will be there in 5-6 years from now. In order to do this, I mean, we have all these possibilities already. Going to larger screens, streaming the services, encryption, digital right management, adaptive streaming. These are already standards, but we need to focus more and more on the bandwidth reduction, capture and playback, but then also I said the live streaming use case with the height rate. And I mean, we heard here, and also from, of course, Vodafone, that video is the main, it is what's going on in the networks, and also proposition driver for both operators. And all kinds of bandwidth saving and high bitrate is, of course, welcome to support these. Then if I leave, this is one extreme that we must support in the networks. The other is then more on the other side. We call it the personal sphere, the wearables, where you have different types of sensors, wearables, connected to the smartphone or directly to the mobile networks. The thing here is, of course, to mention that this must be really simplified RF. I don't think we can support the 40 LT frequency bands in the wristlet. We cannot go even with a multi-antenna elements at millimeter waves. So here we need maybe something else to drive the machine-type communications. Low cost, long battery life. So the performance requirements are, again, low latency, but also then full coverage to be, say, independent of another network. And you can see here today, you can distinguish if these devices today, like the upper one is more like Sara presented, the capillary networks approach, where you connect first with a short range into some Bluetooth low energy or Wi-Fi, and then into the network. Then, of course, the smartphone or a tablet, another thing, is a hub or directly. But if you leave your smartphone for a moment and go away, and you are like myself, I'm a diabetic, I don't want to lose my sugar levels because I put my smartphone there. I need to have the machine-type communications all the time. So I think this one is also important when we drive the machine-type, that you have both connected directly to mobile networks and sometimes into a kind of a capillary network approach. So this is another way of the extreme here. And in order for this to run, I just want to show something. This is going on, maybe not related to 5G, but I think this is a key discussion point. If we talk about this from today's 6 billion phones, and then smartphones, and then 50 billion devices, we must include something about the user authentication. We have the SIM cards today. They have been smaller and smaller, but still they are there. So if I have what did we say, 50 devices per person. Do I need to go into shop and buy 50 SIM cards to put in my devices just to get them connected? Or can we do something about integrating the UICC, the circuit card, to get the authentication? I think this is really one thing that we must focus on within the industry to help this flying for all kinds of the machine tap communications and wearable devices. This is just an example where you reduce the size of the UICC, integrated it. You can download the SIM application over the air and then be up and running. So that's one case here. So from this, going back to see the extremes, where are we today? And this is a very simple kind of extrapolation from the access technology that we have, and maybe into a kind of a 5G. What I just want to show here, that we have two, say, technologies that in the devices by the users are used very frequently. Some use Wi-Fi more, some use 3GPP more, depending where you live and your subscriptions. But they follow each other quite closely, and we think they will follow. Now we're 2014. We will have LTE advanced with carrier aggregation, some 300 megabits per second coming, and we have 802.11 AC with several hundred megabits per second, and both will evolve. I mean, this is the evolutionary approach. Then we go 5G, they will still be there, and they will be evolved. And then we have something new in addition, like on the millimeter wave frequencies to add. But that's not so important, of course, for the end user. The important is to get that, whatever, 5 gigabits per second rate for the high data rates and 8K streaming use cases. So this is one, and we, of course, we know that the evolution continues. There are similar features. We're discussing here new modulation and coding formats, but the multi-antenna, the carrier aggregation, I think these are two, and then, of course, how to make it more dense networks. And then from a device side, we know roughly every 18 months there is a large step up in approach on the platform and the features. One thing then, and it was again mentioned here previously about the RF bands, and I must say that for whatever we discuss here about 5G, for us there are other smartphone vendors and device vendors. There is one thing that is, say, crucial when we talk about LTE from 12 to 16, 17, and all the way to 2020, and that is the number of frequency bands. Because today, the bars here show that how many frequency bands have been defined in 3GPP in RAN 4, and how many, the green one is how many are actually deployed in the world. And then the red is the 3G bands. And you see it's kind of small, and it's even, say, due to refarming, it will go down to 3G bands. And maybe that will be enough. Maybe that will say that we need to go for machine type communications in 3D because we can implement 2 or 3 frequency bands. But if that's not enough, and we cannot have the low power, then we need to do something about the carrier frequencies also for existing LTE for machine type communication, and also depending then on the WRC findings here when we start to adding the 10 gigahertz. As you can see here, we expect here, this is a kind of an implementation of the number of LTE bands in the device, and it goes from, from 5 to 10 to 15 to further away. Then we expect it will, say, stabilize, and then when we add the new complementary, the revolutionary 5G, it will again increase. And this, we must see how to fit that, say, second area to fit into, to make it possible for devices as well. From this, I would just give a show thoughts on the device side, not so much details, but we discussed here about the coverage. And above 6 gigahertz and below 6 gigahertz, I want to show that already below 6 gigahertz, at what we have built prototypes and doing massive MIMO test beds, already at 3.7, the directivity is really significant. And some kind of diversity, what we think will be needed in the devices. So even though we do massive MIMO, we cannot say neglect to having more or neglect having only one antenna. We need to have 2, 3, maybe 4 antennas on the device side, even if we do massive MIMO, because we have the directivity. And if we go above 10 gigahertz, this will be even further significant. So we need to work on some algorithms for antenna selection on the device side to complement on the eNode B or base station side for both for the evolved 4G LTE and for the 5G when it comes here. I have just 3 very simple examples here. I mean, if we talk massive MIMO and everything is put on the base station side of the eNode Bs, of course the base station finds select devices and then can improve the area coverage from several angles. It's like we can say a modern version of a macroscopic diversity or soft handover, but in order to improve the reliability. Then, of course, if you do the same on the other side, you have a device and then you implement different antennas with different angles that can, say, be selected and find the base station. And then, of course, which I think will be necessary to combine these two. And with that, I mean, 5G, we cannot separate, again, the devices from the networks. We need, because that will be on the right-hand side, most probably the required solution where we combine efficient and smart antennas on the devices with a smart and efficient on the base station side. And by this, I also have some ideas when we're thinking, if you just look what happened, if we start, 20 or whatever years ago, huge macro cells, 40, 50 meters high, they are still there, but we also see when we move to 3D, microcells, picocells, and now 4G, I mean, there are tiny base stations. Well, on the other hand side, at that time, it was now we are Sony Mobile, and before that we were Sony Ericsson, and before that, Ericsson. And this is an old tiny Ericsson. It should be like a matchbox size. So this size on the UE, and, base stations this big. Now we see here, our tablet, the tablet is larger than the base station. So what I mean is that there is a trend that we need to think about small size, power efficiency, the number of bands, MIMO solutions, to take into account both aspects at the same time. We cannot neglect one or the other. So from this, how to build up a scenario? We know the requirements, we know the different partners in the ecosystem. We have put together some kinds of, say, what we call key building blocks. And these have been the building blocks or the users or the parts of the ecosystem that we need to consider, whatever we think going forward to 2020. Of course, we had the end user, that in the end, what pays for everything. The device capabilities, what I said. You're buying the devices, then they must support one or the other feature and functionality. And then how do you charge this? Which service provider is included and how is that business model related? And when we discuss, should it be separate or what 5G, is it only a new system or is it a combination of all these? So these are, they say, the extremes, according to, or at least what we have seen, that from the end user, otherwise you are just a creator. You are using your device, you upload 4K, 8K streaming, and you make all the content. Or you're a consumer, you're just streaming and buy and do the charging. On the other hand side, for the device capability, can be what we call a thin, and that is not only in millimeters, but less processing capabilities, less memory, less functionality, so it's just connected to a network. Or you have a thick client where you do most of the processing in the devices. Charging, it can be traffic-based, it can even be free, like an MVNO, you buy a thing and then everything is included. I mean, these could be the extremes when we go into 5G. Operator services, over-the-top services. As you see, probably we will end up somewhere in the middle, but we don't know exactly where. And I think this is really important to take into account when we look at the scenarios. Also, if it then should be seamless, if we say, yeah, there will not be one single 5G air interface, but then the new one to come, should that be fully integrated with interworking, or should that be separate, or how do we combine all these different technologies? And from this, I want to just point at one important trend for this connectivity and for the end users. That is a mobile cloud. We talked about cloud and what it is. But of course, from a service provider point of view, there should be device independent, whatever you do. The device is just a window to the cloud. And in this case, as I showed from the earlier, the device capability is like a thin, really a thin client. And if we look about this from a, say, connectivity point of view, if it's a thin client device, then you must have more or less continuous connectivity and really low latency. While on the other hand, if you're a thick device with memory, and I just heard that before today from Odon, if we can store and do some caching, yeah, maybe we can ease up the connectivity. Again, these are then the trends. So we try to say, what is the 5G? See if I can explain this picture. Otherwise, you have to ask me in the break later. Anyway, I said there are extreme use cases from the really low data rate, machine type communications on the y-axis, to 8K streaming. Then there could be that all the devices will be, say, thick clients, local processing and content, or on the other hand side, very thin, all processing and content in the cloud. Then you can see, yeah, we are like, I said, here we are 4G today. We have some capabilities, so we can do HD streaming, and then we can do something. Not everything, not fully machine type communications, as we heard, that's impossible. But maybe we go towards use case A, or scenario A, then we have some requirements on the 5G, because we can store and cache and do something, but we still need some of the bit rates, but maybe not with the lowest latency. Or we go towards B, where everything is extremely cloud-centric and downloaded all the time. Then for the very low types of devices with the lowest connectivity, without any caching, every sensor, every bit must be immediately transferred. I don't have a memory in my card, but I only have like a modem and a sensor, and to be connected to the cloud. And then, of course, D, you can do some storing, caching, but still very low power. So these are like 4 ways. Maybe we need to cover all 4, probably, because we will end up somewhere in the middle. But I think there could be a focus towards 1 or 2 of these scenarios. So I will just try to wrap up here. There's something about, say, topics towards 2020. Of course, ultra broadband capacity for the services, massive MIMO, new frequency bands, but also from the beginning, heterogeneous network aspects, aggregating the resources of what we have, the evolved, with the new ones to come. And also, as I showed earlier, Wi-Fi, which is still important. I think we must integrate the .11ax, which is now being addressed in the IEEE community. With this, I think we can support efficient video streaming, 8K content, up and down from the devices, and also machine-type communications, low power for all kinds of wearables. That was my presentation.